Hello once again to the Lynn Conway room. We'll continue the afternoon sessions on the topic of calls. And for this, we have Florian from the m.call team.
Yep.
Take it away.
Thanks, Milton. Hello, welcome to my talk and welcome to the nice conference, the evening or the later session. The talk today is about m.call. No surprise, that is also in the title. It is about open, federated, and being decentralized, redefining conferencing for privacy, scale, and sovereignty. So that is a brief overview of the talk. I guess most people heard about Matrix, but to have a self-contained talk, I'll also have a short introduction. What is Matrix? How it works? What are the missing primitives we need to build RTC on top of it? And that is then Matrix RTC. Once we have the foundation, I give an overview what m.call is, what we are using it for, and then we have an outlook what we can do with the ecosystem to adapt calling as soon and as much as possible. So recap, what is Matrix? As written here, Matrix is an open network for secure, decentralized, real-time communication. The real-time here is not RTC real-time, it is messages. It is meant for interoperable chat. VoIP is something we want to build on top of it. We already had demonstrations where someone was building VR and open comms on top of it. Third Room was a very nice and cool experiment in that regard. And we also have a lot of projects which are using it as the fabric for real-time IoT stuff. What Matrix is really good at, it's an open standard, not only open source. So there's a book where you can read how it works and you can implement it as you want it. It is decentral and federated. That's why we love it. Here in the example, you have 3 different Matrix sites. They are all interconnected and you can have shared rooms, exchange messages. That's cool. It's not only decentralized and federated, it's also replicated and persistent. So once a person is joining a room from another home server, the room is replicated there to be especially resilient. Since some years, it is the default also that we have everything end-to-end encrypted, which is very important for privacy. And on top of that, we have verified identities, which is especially nowadays very important because you have fake AI webcams and whatnot. So it's good primitive to have verified identities. But the big question is, does this fit calling requirements? And let's start with a brief history of Matrix calling. I think from the get-go, we already had this native one-on-one calling, quite early MSC in 2014. But one-on-one is a nice start, but eventually you want to have group calls. And at that point in time, Jitsi was leveraged as a widget to bridge that gap, and from there on you could have group calls. Then later, back to let's get it implemented natively within Matrix. The idea was to extend the concept here of the one-on-one native calling to peer-to-peer group calling. And that was a very nice experiment. I remember a lot of interesting challenges to solve, a lot of split brains being in different meetings. And later on, the majority of the calls were nice, but there is a problem. This does not scale to very large groups. And then in 2023, we started playing around with backends like SFUs for further scaling, and this has been proven as a good choice and a good path. But does the different stacks which I just introduced, does they fit Matrix DNA? And Jitsi obviously was not designed for Matrix, so it's not a surprise that it's not fitting all the nice properties we want to have. Federation, large group calls is obviously, that's the reason why we choose it. End-to-end encryption is a challenge. Interoperability is also a challenge, so Jitsi is not a standard. Matrix compatible permissions model and role, not, and standard I already mentioned. The one-on-one calling obviously fits all the other buckets here, but large group calls is the problem here. Peer-to-peer calling, as already mentioned, scales at least to, say, 5 to 8 people, depends on your available network bandwidth, but remains a challenge. And then the element call, development, experiment, how I would call it, is hitting now all buckets here. And the talk here is about to explain what we have changed in Matrix to get eventually there. So, from before that time, the question is, does Matrix fit calling requirements yet? And a lot of checkboxes is some we can check off here. Already mentioned decentralized and federated, replicated, persisted, end-to-end encryption, and verified identities. But the question is, reliable RTC? It's a to-do. What is the RTC challenge? And RTC really in the sense of real-time data. Due to Matrix distributed nature, net splits, partitions, and what all is possible and is also intended, is that you have eventual consistency as a consequence, and quite often race conditions. While this is not a big problem for messages, if a message takes 10 or 15 seconds to arrive, that's not so cool if you want to start a call and people join at very different times or even miss a notice that the call is happening. Hence, typical symptoms which we had in the past: never-ending call ringing on your second device. Who was affected with that? Yeah, I see. Ghosts, split brains, partitions, multiple parallel calls. That was the early days, so. And then an evergreen glare, which is causing conflicts in state machines. It's like two people are speaking at the same time, and unlike humans, computers have a hard time to recover gracefully. So we need to be smart here. And this leads to the conclusion: we need new matrix primitives to circumvent those challenges. And on top of that, it is super important that these new matrix primitives are not a game changer, but they are just a small addition such that we can fix or address those issues here. And this leads me to what we then called Matrix RTC, which is the layer on top of Matrix which enables real-time communication. And by the way, tomorrow in the Lynn Conwell, 15 o'clock, there is an in-depth talk which is really going down the rabbit hole of Matrix RTC. I can really recommend that. Obviously, we want to make RTC a great and important and central part of Matrix. And RTC is not just video conferencing, it's really all think beyond calls. So there was this nice experiment of third room where you had a virtual room which you can run through, and all the data modeled here went through an RTC system. Then there's a talk Saturday here about NeoBoard from Nordec, which is also using RTC technology to synchronize data blazingly fast across people attending a whiteboard. Since we know that the internet and the world is moving fast, we want to have the backend, which is hosting the actual RTC data, pluggable. While WebRTC is a nice technology we can use nowadays, it might be that we want to use web transport or web codings going forward. Hence, it's really important that this is pluggable. Today, we are using LiveKit, which is basically doing a nice glue layer around WebRTC, such that it is having a nice developer-friendly API surface around it. Yeah, and the main motivation obviously was we have large matrix rooms already, so we also want to have large interoperable secure group calls on top of it, such that everybody can join. And that is, given a matrix, we want to support it in as many clients as we can have, which fits the idea of being interoperable. So, Matrix RTC at a glance is intended as a structured RTC framework. And the first layer is defined by so-called RTC applications. The RTC applications, they define the activity type and the application logic, and they're giving meaning to the data. So if you have a whiteboard, for instance, the data could be a mouse cursor location on the screen. If you have a call, okay, then it's video and audio, obviously. But you can also think of a game, and then the position of the ball or whatever might be the meaning of the data which is transmitted. What we learned very hard in the last half a year is that due to race conditions and eventual consistency, you need to define something like a good place. We call it a slot, where people can meet with the same intent, an application, to gather around there and have a call, have a game, whatever. On top of that, slots are basically managing the application. And in order to manage a slot, you need slightly higher power level, being a moderator, such that you can open or create, open and close slots. And you can have as many slots as you wanted in a room, each for a different purpose, obviously. And that's nice if you have a slot and application, but without membership, there's no RTC application running. So the membership, the RTC membership, is representing a device or a participant who is taking place in an application. And it's also, on top of that, providing the information how that participant wants to be reached via which RTC technology. So this is what we call an RTC transport, and every participant is announcing, hey, I'm available via WebRTC, another participant might be available via WebRTC and Web Transport, and so on and so forth. That's the idea, being very flexible here, and that also the users are in control where they want to publish and subscribe media. Yeah, and then to formalize the transport also here as well, that is what I also already mentioned, that we want to have pluggable transports. As of today, we have the LiveCat transport, which is well defined and also has an own NMSC. But going forward, we want to have more. And that's intended that we, at the given point in time, want to use the best technique at that given point in time to do RTC. And the last building block here, obviously, is end-to-end encryption. The idea of a MatrixRTC session is a session is taking place in a matrix room, but most of the time only a subset of those users are taking place in that RTC session, and hence we need an end-to-end encryption schema that we can address subgroups in a room to exchange end-to-end encryption keys. The two things, I'm starting with the first one here, which we learned the hard way last year, is that, and we already heard it in this room by a lot of talks today, we heard this problem here about floating room state. So if you have, if you model your application through matrix room state, after a long period of time, you gather a lot of different state, and if new people are joining that room, it will be very slow for them to join that room. So we needed to find a way how we can model state in a room without contributing to room state float. And therefore, we invented a new matrix primitive, which is called sticky events. Sticky events is first of all, end-to-end encrypted. That's pretty cool, because now we have way less metadata which is available on the server. It has the same reliability guarantees as room state has, so it's really passed down to the clients reliably. And on top of that, since we are not using room state, it's more efficient because we don't have state resolution to carry out. So sticky events reduce the metadata and increase efficiency. That's the essence of that new primitive. So what we did the last half year or year, we concluded our research and development efforts on the topic of MatrixRTC. Therefore, that was already done last year. We invented the delayed events. They do contribute to a precise tracking of the lifetime of a MatrixRTC member. We invented the slots system here, which is the management for RTC apps, and the last one, which I already presented here the sticky events, which are reliable and lightweight way of modeling application state. That's here in numbers. If someone wants to read it, I'm pretty sure the slides will be available later. This is just to see, it was really a bunch of work to get this all orthogonalized and written down and to give it a common thread. Implementation-wise, we have everything implemented in Synapse and also in the JS SDK. The other SDKs will follow soon. It's really that they will follow soon because we need them also for our products, so trust me. There's one specific MSC which I want to outline here a bit, and that is called the m.call application. It's the MSC 4196. It is standardized, the first, okay, we wrote it so it was easy to be the first standardized Matrix RTC application. And the idea is it is the lowest common denominator for calling in Matrix. And the idea really is that every application, every chat application should implement it such that we can have calls across Matrix with all kinds of clients. The supported call types which we want to have is obviously direct messages, so one-on-one. That is where the whole party started. So private peer-to-peer conversations. Huddles is something which is important. So if you're in a room discussing and then you want to say, come, let's have a short call and discuss it. So for spontaneous group discussions. But we also thought of something like a persistent social room in the style of Discord, which acts as a permanent hangout. And with that introduction, it's time to move to element call. So now we have all the ingredients to build on top a calling experience on top of Matrix. And the idea is that we do cover all interesting or all video call scenarios. Starting with the telephone use case, which has ringing by default. Then the ad hoc chat, the huddles. You start a call in an existing room. Ringing is part of your notification settings, so you can choose. And for conferencing or standalone application, we have a SPA here, single page application, which is easy to share links for, especially people who don't have a Matrix account, and it features guest access. So that you can create a link within your Messenger application for external people, and then they can join your meeting. Is Matrix calling a thing? And that was also a surprise for me. So last week I gathered some statistics from the SFU instances we are hosting. It is here meeting minutes per month. So we have here in blue the conferencing use case. And that scales up roughly, if we round it up to 1 million meeting minutes per month. You can see here a dip in the holiday season a bit. And what was also surprising to me is that the in-app use case is really something people are using. So on matrix.org, we are going up here to roughly 10 million of minutes per month, which equals to roughly 20 years of meeting data. That was impressive. So the conclusion is, yes, calling is a thing, people are using it, and the bug reports we get in return are really neglectable given the amount of meeting minutes we have. So I could say the effort the team really put into MatrixRTC paid out, and it seems that we are at a position where we could say, yes, it's stable. From last year to this year, there's also a mental shift in terms of ownership. So previously it was that if you are in a federated scenario like here, that you needed to elect one of the SFUs alongside the home server, and then everybody was meeting there, and this does not really fit the Matrix DNA. So this year we thought, okay, we need to improve here. So the mental model is, for each of the home servers here, A, B, and C, you have alongside an SFU. The others will appear in a minute. Just for simplicity, we are starting here with the home server B. And this is simple because we only have two users here, B1 and B2, and it's easy to gather that they are using the SFU, the red one here, to have their meeting. Let's make a different example. We have the SFU over here at home server A. starting with the same example. So currently in the meeting room 456, we only have user A1 and A2. And now a user from home server C is attending. That is the user 3 here. And now it's getting a bit more complicated. Can I go here? I think so. So now we have new connections. The user from home server C is publishing their media to their local SFU, which is then picked up by the users from home server A and vice versa. And this way we can, we have a very fair distribution of backend resources doing so. And the other thing is, in every time the user has the ownership, they can decide if they want to consume the media from the remote ones or not, and they do upload media only to their trusted SFU. Even if it is end-to-end encrypted, there's every time a bit of metadata, and that's the reason why people might want to choose I only upload to my own SFU. The other interesting concept with this multi-SFU approach is that it's now very easy to differentiate between remote users, which are restricted, and local users, which do have full access. So we implemented for the RTC live kit transport an access model here, where full access users related to the Matrix side can publish and subscribe media, as well as there is the live kit resource on the SFU, they call it live kit room, also triggered in advance. And if you are a restricted user, so you want to join someone from the other SFU, then you can, it is not triggered to create a room, and you can only subscribe to media. So we have a very nice access model here, which really prevents it secures your infrastructure, so it cannot be used unintentionally, and it is at the same time a very fair process. There's another thing which I wanted to mention. So in discussions with customer, quite often there's a discussion about network bandwidth. And for whatever reason, there's a meaning that if you're using an SFU infrastructure, you have to use, or that more network bandwidth is consumed compared to a MCU system. And that is not true, because nowadays we have very sophisticated and intelligent SFUs. And here's a simple example how that works. Here's the publisher, that's the webcam. And this webcam stream is published in 3 different quality levels. Medium, low, and high. And it is only transmitted if someone from the subscribers is actually requesting that quality level. And by doing so, if you do the math, in the end of the day, you have very comparable network bandwidth usage compared to MCU. That's the reason why I want to really present this here. SFU does not consume more network bandwidth than an MCU approach. But it gives you a lot of properties. And the most important one, especially for Matrix, is it is end-to-end encryption. You can do end-to-end encryption, and therefore you need an SFU. We did some experiments on a quite regular AWS machine. In a single machine, you could host up to 500 participants. So that's quite decent. And you can have horizontal scaling using the typical Kubernetes primitives. The other question I quite often get from customers is, so what about out of beta? And this year, believe me, we are very close. So we really fixed the Matrix RTC. Not laughing here. We fixed Matrix RTC. We added 2 new primitives, which are super powerful, and they are also proven that they really solved the problem. Feature support is what we would expect from a regular video conferencing solution. So you have a meta space which gathers all the video conferences. You have screen sharing, emoji reactions, raise hands. On the mobile platforms, you have native call kit integration, a handset mode, and picture-in-picture. So we use it since a year, and it feels nice. And with that, we have a next topic, outlining the future. So I have Aaron here. Aaron's our designer, senior designer, being responsible for a lot of stuff, but also for VoIP. And he will walk us through the design philosophy. And the cool thing is, we started already implementing it, and you really can expect the first chunks being delivered this year.
Hello, thank you. Yeah, so I'm a product designer at Element, and I'm going to walk you through the vision of what we're intending for using m.call in the Element app for both web and mobile devices. And we focused on those two use cases, so one-to-one calling, which is a much more simpler focused experience, versus group calling, lots of people, features like raise hand, etc. So I'll just take you through a couple scenarios, starting on a mobile device. For a one-to-one person, you can either video call them or voice call them. And if you video call, you get a dedicated experience while you're waiting for that person to connect. You've got your basic controls to turn off on and off your video. You can change your camera orientation if you want to. But then they connect, and now it's just you and that person, large and in your face. And support for landscape if you'd like. And if you're on the call and you really need to do something else, we made it possible to minimize the screen, and it gives you this nice little clean banner at the top. Opted not to go for picture-in-picture in this case for two reasons. One is if you're participating in a call, you really should be participating in the call, not doing multiple things. But if you really do need to, then that picture-in-picture is always in your way. It's at the bottom of the screen when you're in a timeline, or it's at the top of the screen when you're in the chat menu, chat list. So it just made it a very clean banner to let you know that it's still active. You can mute yourself if you want. You can always get back to your call. And then at the end of each call, you can give a little rating and give us feedback, like a lot of other modern apps do, just to always give us some sort of feedback as to what is working or not working. And then the other is if you just want to call someone with a voice, automatically by pressing that button, your camera is off and waiting for that person to connect. And then it's basically, you get this little animation of the sound waves coming from their avatar, but at any point and you want to switch to video, if you both switch to video, then it's a video call, or you can just be sharing your video. So you can always switch back and forth between a video call and a voice call at the tap of the button. And again, minimize. And then on the website of things, let's say that you're receiving a video call. You would get this banner. You have an incoming video call that you can then either accept or decline immediately, but maybe you would rather go to the lobby and turn off your camera or mute your microphone for a second because it's noise in the background, and then you can join. And you notice that the chats is now in the right sidebar, so you still have access to that, but you can always collapse that and enlarge your video experience. And when you're receiving a call, here you don't need a lobby because by default you're not sharing your video. So if you accept, then you do get kind of like a picture-in-picture like thing that will follow you around, so you can continue to chat with this person or whatever you need to do, and having access to the controls without it dominating the interface. As for a group call, right, so let's say you want to initiate a group call in the room. Now, here again, you've got your options to mute your microphone or your video, change your thing. But then as you join, now you've got the presenter tile at the top of the room that's always persistent, and that sticks with you as other people join. And so now you won't lose the actual presentation going on or the conference call going on while you're scrolling through the other members. And if you want landscape mode, then it's basically like a full screen experience. It gives you access to all the controls on tap. And you can get to the list of participants at the tap of a toggle. And and then we have the much loved hand raise emoji, which when you do that, you can see your tile or anyone's tile is illuminated in this orangish color. And you can either tap down here to close, or you can just tap the button there to unraise your hand. So I wanted to make it very flexible for people to know who's waiting to be heard or to be asked their question. And other little information like how many participants at all times is pretty helpful as well. And then on the website, room receiver, let's say someone has initiated a group call. Again, you get a banner. You can go to the lobby if you'd like, or join directly. And this is probably familiar to most people. You can see all tiles, and the speaker is always at the top, or you can focus the experience and just focus on whomever is speaking if you'd like. And then you can always expand or even do full screen if you'd like. And then in the timeline for a group call, if it's still going on and you have left the meeting, you can always rejoin the call easily from the room header. So that's basically an introduction, or just a taste of the vision that we've carved out for what this should look like in the apps very soon.
So then, the ecosystem. So now we saw that the path, how m.call will adopt all the m.call features. And we also thought that while we crafted MatrixRTC, it would be very nice if bootstrapping the ecosystem is fast. And therefore, there's one paragraph here in that MatrixRTC main spec, which is a lot of text, but basically it's saying, ideally, each application should provide the Matrix widget that can serve as a reference implementation for clients, which makes the adoption of that specific feature quite easy, because the only thing you need is to implement a widget driver on each platform. We already did that on the JS SDK, and the React SDK, and the Rust SDK. And here in the picture, you can see how that works in essence. So you're bundling the widget within your application, and then through the widget API, that RTC application can act as a Matrix client talking to the Matrix home server, and is also using then, here in our case, the LiveKit SFU, the MatrixRTC backend. And the idea was that we today showcase here quickly how you can add m.call to a specific client, and we choose the Cine client for that. And for that, I hand over to Timo from the VoIP team. We need to change our notebooks here. What can possibly go wrong? And Timo will walk you through how that works. Timo's also from the VoIP team, and yeah, the stage is yours. I think I need to, yep.
Okay, thank you for the introduction. Yeah, I'm Timo, an engineer at the VoIP team, and we already had this story, like we want to do like m.call as a widget and everybody can just add it to their clients. But we thought it also doesn't hurt if we kind of give a precedence so people can actually look at code, how this works. And I will go a little deeper in this in the talk tomorrow, but just to give like a somewhat overview, I'm showing you here the diff. We'll scroll through it and you can see like the general gist of it, and it's really not a lot of code. And some of the most central parts are already in here. Like we, of course, need to get the embedded version. So it doesn't even rely on some third-party hosted m.call. It will be embedded in this final web app. And it needs the widget API. Then there's a couple of stuff we need to copy over from Element Web. As I said, I will do more details. And then it's basically just one file for a call view. That's just a React view with an iframe. And then modifying the room header and modifying, that was like actually adding the view to the thing, modifying the room header. And at the end, we need some helper functions. And that's already it. So it's really like a okay piece of work. Biggest part is actually copying stuff over from Element Web. And now if we start this, we can go ahead and wait until this is reloaded. See how quick the internet is. And we should already be logged into my test account. And we should have a room header in a room with a custom button that allows us to start an element call. So here I'm currently in a DM with Florian. It totally would also work in a group chat. I can press the start call button and it will load the widget, which is already embedded, and do all the necessary things to. It even rang on Florian's phones, so even sending the notification event is part of the widget code. And Florian, I totally should mute myself, and Florian can join the call. And this is like a full MatrixRTC based video call solution in Cine, which is kind of nice. So I'll hang up here, and that's it for our element call demo.
Thanks a lot. Let me switch back. Whoop. So, and with that, we already come to the summary, the conclusion. MatrixRTC is ready for calling. We already delivered more than 139 years of non-stop meetings on call.element.io and matrix.org. And in comparison, the bug reports were really low density. So it's cool, it's working. We also had the vision that we standardize how matrix calls work with the m.call application here in the MSC 4196, matrix voice and video conferencing application. We made a reference implementation using the element call widget approach for the m.call application. We have a very deep integration of that widget in the element apps, including CallKit and picture-on-picture on the mobile applications. And we also adapted all of our software stacks such that MatrixRTC compatible sites deployment is very easy to carry out using the Element Server Suite Pro. And for all of that, in theory, yes, you have some in-depth talks. So the MatrixRTC in-depth talk will be tomorrow, 15 in that room, and the Element Matrix site talk will be in the other Byron room. And with that, I want to conclude my talk, and I'm happy for questions.
So I guess we can start. We have some questions in the chat room, but we can start here in the physical room. Oh, yes.
Okay, so first, thank you for the presentation. I think it's good to see a lot of development in the element core. I just have an extra question about the desktop implementation. Because currently all this is in the widgets, and we are talking about the web version, but there's the use case when we use the app on desktop. For example, many like app like Team, they have or Slack, they have like a very well-rounded desktop version, which the call would happen in an extra window. So in Electron, it would behave differently. And how are you handling that case?
So the Element Web is also, or we also have an Electron app, Element Desktop. It's also an Electron application.
Yes.
And there you can also embed that widget. That's not a problem. But you are asking, you want to pop out that window? Yeah, okay, I see. Yeah, that is something you can absolutely do. So that is not a problem.
Yeah, but I was wondering if you are actively developing similar thing or this.
It is on our agenda, but it's not the first thing. So first we want to implement the nice layouts we have seen. And after that, this is something we can discuss. Yeah. But you're not the first person asking this. So.
Yeah, because I mean, it's quite popular that they use desktop for that. And it would be nice if everything is also work in the new window. And the PIP view also work there. So
yeah.
Okay, thank you.
Okay, now one question from the chat room. Can restricted access users also send their audio video?
No, and so for that specific RTC transport live kit, the live kit transport, the idea is that it is a multi-SFU approach, and you will ever upload your media or publish your media on your home SFU while subscribing media from the others. So no, you would not be able as a foreign user to publish media on that SFU. Yeah.
Okay, another question from the physical room. If not, I think I have a couple more here. Are there any intentions for forwarding system audio during a screen share session?
That is an evergreen, yeah. Getting audio over a screen sharing session is very hard to do. So first of all, so the simple solution for that is you're using a Chrome web browser where they have the feature that you can share audio for a screen share if you share a Chrome browser tab. That works. If you want to share screen from your desktop or from your mobile with audio, that is nearly impossible because if you're using the web RTC primitives, they are quite limited. And you also are running into another very hard problem. So let me try if I can explain it easily. If I'm capturing the system audio from my desktop, it also includes the play out from the video conference. If I'm playing that back, the other person from the other end will hear an echo. So you need an echo cancellation system which acts between the video conferencing solution and the system audio. Nowadays, the operating systems have more privacy, so they don't give you access to the playout signal, the system out signal. So that is really tricky to do. You could do it quite easily on Linux. If you're using something like Pipewire, then you can just reroute the audio of that specific application into the video conference application. That would work. But a general solution which fits easily all use cases is very hard to carry out. So long story short, it's hard.
Okay. Anyone else in the room? I have a bunch of questions in the chat room, so I guess I'll go through them.
Okay.
If someone wants, just raise your hand. So I think you sort of answered this, but can we have audio-only calls and audio-only rooms?
Yes, the answer is yes.
Okay, so that
So
was...
that's something we have on the agenda, and it's also easy that you can up and downgrade basically between a voice call and a video call. Yeah.
Another one. If MatrixRTC SFUs don't decrypt media, how do they handle features like active speaker switching or simulcast quality control without breaking that end-to-end encryption?
That is a good question. So the client is being responsible for asking for the right resolution. And this is easy to do. You can have a look how big is my tile, which I'm rendering on the screen. And if it's the small one, I'm just asking for the small video stream. And if it's the big one, full screen, then I ask for the high quality stream. That is easy. The question about the audio indication, so the speaking indication, that is something the client is sending as metadata to the SFU. And that is how it works. And from there, it's then distributed.
Okay. In the room? No? Another one from the chat room. So I'm not sure if this is specific to MatrixRTC, but how does it work for end-to-end encrypted chats in a room? Does it use a single key, or does each user have their own key that is rotated with the room or server?
So it's a very good question, and I answer it for both, for how it works with messages and also for calls. So for messages, it's a MacOM session, so it's individual sender keys. And we are doing the same also for VoIP. Here we can't really use MacOM because the way how the encryption works in WebRTC is slightly different. But we do have individual sender keys, and they are also rotated every time the membership of the call changes to have the properties of forward secrecy and post-compromise security. For very large calls, also the what we currently have for the full screen experience, we are using a single shared password. And that is being part of the slot. And we remember the slot is the thing which manages the application. And there you can decide if you have a single shared password for all participants or if you go for the individual sender keys. And obviously we would most of the time prefer the individual sender keys.
Okay. If there's not any further questions in the room, I'd say let's give it another applause for Florian and the Element Call team.
Thank you.